Hey everyone, and welcome. Today, we're diving into something really cool, a totally mind-bending idea. What if the future of artificial general intelligence isn't about creating one single master algorithm? What if instead it's about learning from the history of physics? We're going to break down a brand new framework that connects the worlds of Newton, Einstein, and quantum mechanics to build a smarter and way more adaptable AI.
Think about it for a second. You've got an apple falling from a tree. You've got a black hole literally bending the fabric of space and time. And then you've got an atom doing things that they defy all common sense. For hundreds of years, we've known that these different realms play by completely different sets of rules. So how on earth is a single AI supposed to make sense of all that?
Okay, so to get our heads around that, we gotta start with a classic problem in physics. And trust me, it's the perfect analogy for the huge challenge that AGI is facing right now. So here's the kicker. Physicists don't actually use one single theory for everything. They're super pragmatic about it. When they're dealing with the everyday world, cars, baseballs, stuff like that, they use Newton. But for things like GPS satellites or giant black holes, they switch over to Einstein's relativity. And for that absolutely bizarre world inside an atom, they've got quantum mechanics. It's all about picking the right tool for the job, right? Choosing the right lens to look through. And this is the light bulb moment for this whole explainer. What if we could actually build an AI that copies that exact strategy? An AI that stops trying to find one single universal theory of everything, and instead just knows how to switch between different models of reality depending on what it's looking at.
All right, so let's check out the solution they've come up with. It's called the Physics-Based Reasoning Framework, or PBR for short, and it's a really elegant way to build an AI that can handle all these different realities. And this is the absolute key. See, the hunt for a single master algorithm can actually backfire. When you try to force one model to learn everything, it becomes fragile, kind of brittle. It gets confused and makes mistakes when the context changes. So the idea here is don't do that. Instead, build a federation of expert minds. It's about prioritizing smart thinking over some grand unification. It's not about having one single truth. It's about being smart enough to adapt its thinking to whatever situation it's in. And here's what that federation looks like in practice. You've literally got a Newtonian module for our everyday world, an Einstein module for the cosmic stuff, and a quantum module for the super tiny atomic world. They're all just sitting there, side by side, ready to get tagged in, like specialists on a team.
Okay, but how do you manage a team of experts like this without it all turning into complete chaos? Well, you need some seriously clever managers.
So let's meet the management. First up is the domain dispatcher. Think of this one as the ultimate decider, kind of like a traffic cop for thoughts. Its job is to look at a problem, figure out the scale, is it big, is it tiny, is it cosmic, and then it activates the right expert model for the job. And then there's the boundary guardian. This is your watcher, basically the border patrol for reality itself. It keeps an eye on those fuzzy areas where one model's rules start to break down and another's need to take over. So here's how it all plays out, step by step. First, the system looks at a problem and figures out the context. Are we trying to predict the path of a baseball or the light from a galaxy billions of light years away? Then the domain dispatcher jumps in, points to the right expert and says, "You're up." And all the while, the boundary guardian is keeping a close watch. If the problem starts to shift, like say an object starts moving close to the speed of light, it flags that uncertainty, basically signaling that it might be time for a different expert to take over. Now, to make sure the handoffs between these models are super smooth, the system has a couple of clever tricks up its sleeve. For one, it's uncertainty aware. That means when it gets near one of those fuzzy boundaries, it holds on to a few different possible answers, kind of hedging its bets. Second, it uses something called satisficing, which is basically a mashup of satisfying and sufficing. All it really means is that it prioritizes getting a good enough answer so it can take action instead of getting paralyzed searching for some perfect, absolute truth that might not even be reachable. But this whole framework, it's so much more than just a clever bit of engineering. It's really a new philosophy for what intelligence even is. The first big idea is this concept of multi-Umwelt. Now, Umwelt is this German word that means the specific world in animal experiences. Like a bat's world of sound is totally different from our world of sight. So this framework is basically saying that for an AI, reality isn't one big thing. It's a collection of these separate functional worlds, and there's no real need for one grand theory of everything that connects them all. And that completely flips our idea of what it means to be smart, right? It's not about just cramming a ton of facts into one giant brain.
Real intelligence, according to this, is all about context. It's about having the wisdom to know which model, which lens you should be using in any given situation to get the best results.
And all this leads to a final, really pragmatic point. The goal here isn't to find some single, unified, absolute truth about how the universe works. The goal is to build a coherent system that can make sense of all these different contexts and, this is the most important part, take effective action in the world. It's about being useful, not getting bogged down trying to find some abstract, absolute right answer.
So I want to leave you with this final kind of provocative question. Because when you think about it, we do this all the time, don't we? We switch between being logical, emotional, intuitive, different mental models for different situations. So if we actually manage to build an AI that can consciously and formally jump between completely separate physical realities, what does that tell us about the hidden structures of our own minds and the very nature of the reality we think we see every single day?